Good day to all of you, wherever you are in the world. I'd like to welcome you to IGLC28. Today, I will share with you our paper on agent-based modeling and simulation of construction crew performance. The authors of this paper are Shehab and Ali Ezzeddine from the American University of Beirut, myself, Hamzeh from the University of Alberta, and William Power, who is the Productivity and Performance Manager at the DPS Group. So the agenda for this paper presentation is first we're going to start with the background on simulation and the last planner system and the need for the study, and we're going to move to methodology and research objectives. After that, we're going to discuss the tool that was developed for this project, and we're going to present some results and share with you conclusions and future work. We all know that the majority of construction projects suffer from delays in their schedule and in addition to other cost overruns. And we have seen from research that productivity in the construction industry has been declining for the past years. Research has also shown that the majority of construction projects suffer from uncertainty in project objectives and project needs at the beginning of the project. And several of those uncertainties have actually impact on workflow and resource availability. We also know that planning and control is at the core of construction management processes, and any improvements that can fall in planning and control can have a huge impact on project performance. And this is what this paper addresses. Regarding simulation, we, as you know, simulation has been used in construction to study, analyze, understand, and improve construction systems or processes within a construction system, and have shown positive impacts in terms of lowering cost or optimizing schedules. There are several software that were used in construction simulations, such as Cyclone, Stroboscope, Symphony, and AnyLogic. There are three main methods of simulation that are used. These are discrete event simulation, agent-based modeling, and system dynamics. In this paper, we're going to focus on discrete event simulation and agent-based modeling because these are the most applicable to construction operations. Discrete event simulation is useful for construction modeling because it can show the dynamic nature and stochastic nature of projects, and it can be incorporated into the modeling. It is also process-centric, where it can show a chain of activities and the linkage with resources and between those activities. Agent-based modeling is also very useful and applicable to construction operations because it can show the agents and their interactions, and these agents can be humans or information or computers or equipment or others. And it can show also they're able to reflect the high complexities and interdependencies within construction systems. And those agent-based models, they have three aspects. They identify agents within the system, they show the agent relationships, and they show also the environment where the agents live. As you all know, the last planner system has been used for a long time to improve reliability and project performance. It comprises several levels of planning, namely master scheduling, phase scheduling, look-ahead planning, and weekly work planning. This paper focuses on the weekly work planning stage of the last planner system, and it mainly tackles a major problem in construction where project managers, they usually use wishful thinking in projecting their production rates. And usually when we are midway or through execution, we tend also to adjust and also use some wishful thinking productivity rates to measure the remaining duration of activities within a certain week. This paper, actually, the goal of this paper is to present a method that can give some realistic, project some realistic durations and productivity factors for activity. The paper uses for this several metrics developed for the last planner system, mainly percent plan complete, which measures the reliability of planning on the weekly work planning level, percent reliability index, which measures the reliability of planning at the activity level. Also, it uses another metric called capacity to load ratio, which measures the ability of teams to properly match capacity to load within a certain week. Also, percent improved complete, which measures the reliability and commitments of teams at the weekly work planning level to implement improvements to the remaining schedule or the remaining activities within a certain week. And those were published before. So methodology and research objectives, the main methodology was used was simulation. The objective was to use simulation to integrate unforeseen conditions and previous LPS metrics from a certain project to better calculate crew production rates that are more realistic. So it uses as inputs data on duration of the activity and data on the minimum mode and maximum values for these metrics that I mentioned before, which is PIC, PRI, PPC, and CLR. Then it uses engines in discrete event simulation and agent-based modeling to forecast some more realistic production rates. In this paper, they are named improved production rate. For this project, this methodology was applied on, or we used some data from actual projects, and one of the projects that we use data from for this study is a pharmaceutical construction project where the data acquired spanned 94 weeks. And what we look for in specific is the reasons for non-completion, because this will be used in the agent-based model to predict uncertainties. And here we have different reasons for non-completion and their frequency within the 94-week period. Then we used agent-based modeling and discrete event simulation. So discrete event simulation was used to model the activity durations and the relationship with the resources, with the crews. And then, which was shown in figure 1 here. And in figure 2, we see here a user dashboard where the user would enter data on these 4 last planner system metrics, PIC, PPC, PRI, and CLR, in terms of minimum mode and maximum figures. Also, the user can enter the time left to improve. So here it can be either the beginning of the week where you have 5 days to improve, or at the end of the week where you still have 1 day and you want to improve the remaining performance for this activity. And the user would have to enter also congestion ratio, because we're taking space into account to better predict productivity performance. Figure 3 shows the different reasons for non-completion with their probability of occurrence. Agent-based modeling was used to show the different states that the agents, here the crews, that can be in terms of working or idle. And if they're idle, they are idle because of certain reasons, and these reasons were mentioned here in this figure. And the data from the project was used to actually measure those idle times. And then from those, the models are run, and hopefully a realistic approximation of the rates, productivity rates for these crews are. I'll share with you some data. So this is one of the activities or one of the experiments that was used to verify the model. So here we have used 3 different scenarios, one with good performance where you have a high level of minimum mode and maximum for the LPS metrics. Then we have average performance and bad performance with a certain level of congestion. So here we can see for those teams that they have good performance and low level of congestion, there's the mean probability for the remaining duration is low, and the probability that improved production rates are probable is high. And this actually goes down as the performance goes worse and as congestion goes worse. So this is actually a very good verification that the model works. So in the future, so as a conclusions, we can show that the model actually works. It uses inputs as time left, group performance metrics, and level of congestion. And the agent-based modeling uses reasons for non-completion and uncertainty. And the model output uses productivity improvement for crews. Future work actually aims at getting better accurate information for these LPS metrics and testing it on several case studies, and also automating this framework to develop the tool. Thank you for listening, and we're looking forward to receiving your comments and answering those questions in the live sessions in July. Thank you so much. Have a good day.